And about 3 years ago, we had an opportunity to get involved in the production of biogas. Why does that matter? So if you haven't heard, the joke about like cows farting and belching, it is true that there is a significant amount of methane that's created through the decomposition of dairy manure specifically, whether that be in the cow's stomach and they belch, right? Or whether that be in the manure. And one of the ways where we thought we could add a lot of value to this space was to focus on capturing that methane from the manure. From the cow to the lagoon. And the lagoon is just a big pond of food, right? And that's some pictures in later slides. Our process, all we're doing is capturing the organic process that's already happening. So cows eat silage goes into the cow, through the cow's stomach. A lot of it does not actually get broken down in the cow's stomach, or they're like 5 stomachs or something like that. But through that process, a lot of it doesn't get broken out. A biogas stream. We actually, again, as a Dublin, Ohio company, chose Guild right down the street to. They have a microgate and nanogator. They have a pressure swing absorption separation system that we have purchased. And so we partner with Guild for all of our sites to do the separation. From there, we have 2 streams coming out of Guild. We have almost pure methane. And when we all talk about natural gas that heats our homes, that is mostly methane. It's got ethane and propane and some other hydrocarbons in it, but it's mostly. It takes just 5 cows worth of gas to create that. So 5 cows equals 1 house. And so 1,000 homes worth of heat. And then here's just our layout on the injection site. So again, purchase land, you can kind of see trucks pull in, they back in, and then they can leave. And that data has to be retained for 10 years. And so, as frustrating it is, we've had situations where we did the thing, we made the gas, we put it on the pipeline, but because we had a meter go back, that's been a really frustrating thing for us, and something that Todd's really been helping us out with is like, how can we set up, whether it's our equipment or even we're looking at getting some secondary metering now and then tying that in, because the government will say, well, if you have 2 meters in a row and one fails, we will allow you to use that backup meter set, but it's tricky. So having a solution for us that can take in all of this data was really important. And now from an operations team perspective, we can start to do some really cool things with that data and get some really cool insights. So just I think I'm about to hand it over here to Todd, but a couple of things that we're really focused on, collecting the data from multiple different vendors. So one of the things that these farms seem quite large, and they are, but they're still kind of small in the industry. We were trying to get into a pocket of dairy farms that were just below where everybody else was building. So we had to be pretty cost effective. We didn't have the budget for these sites to have $300,000, $400,000, $500,000, fully integrated SCADA solutions or whatever it is that you wizards do. So for us, what we decided to do instead is we will use the PLCs that each vendor provided, and we're not going to go to that vendor and say, you have to work with this company and we want to be able to push data to you and change parameters on your screen. We're going to use your screen, Mr. Vendor, but I still at least need access to that data. And so what we had is the ignition device sits, at a site and collects data from 4 or 5 different vendors that are consistent for us from site to site. And it's really given us the capability still for our site operator to go into the various vendors' portal or screen to control things, but still have a user experience and a data management experience as if it was a much larger, fully integrated system. I talked about tracking for federal and state agency programs. We wanted a UI that was clean, intuitive, easy to understand.
We're going to talk about this application, kind of what we did and how we got them to a solution. The first thing, just a quick overview of the project. We do have one of our boxes. This is something that is deployed at every site. Something super simple. We've got an ignition application that's on the PC. We have access through a network of simple power supply, a simple box. This gets mounted. This is what you see at the site. And we'll go through the application. I'll show you kind of what's on this, what's running. But this is basically what we give to them. They install it, add a network, and then we basically connect it to the Ignition hub. So what was the problem? So IGS has all these farms. They're needing to collect data, as David said. The application we end up providing them is something that makes it easier to do. So think, they got all these farms, they want to add another farm. We got to add all this data. So at some point, that's a cumbersome. It's a lot of work to get all that connected. So the other thing is they want to expand quickly. So as the amount of cows that they're bringing on, there's new farms. So you've got to get, okay, we have a new farm, we got to have it up and running. There's a cost to that. So the sooner we get something deployed, the better. So that was one of our challenges, make it cost effective. And then accessibility. So you got all these data points, it's like, again, you're not going to go to whole SCADAs, HMIs. You might have a brand that that's all it talks to, right? And then you got to pay for something else to talk to another device. So what's really cool with Ignition is they have all these drivers, and I know they're adding. So there's different things. So they've got red lines, which are, one vendor is working with that. You've got another vendor that's using Allen Bradley, different PLCs. So you have all these different vendors, and again, separate companies, they're not working together. Obviously, they have one goal. So it's like, how do we get all these things connected? And as you guys see on your plant floor, you add a device, network connectivity is challenging, right? It's like you have different protocols, device net, all these different things. It's like, how do you get this stuff talking? So one really neat thing is Ignition has quite the collection of comm drivers, right? All the different devices. So, we have a red line. It's got Modbus TCP. Pretty sure Ignition has that, right? There's a connection. So we have all these farms. So one of the other challenges is, how do you link all these farms? They're independent sites. It's not one company. You're not in a plant where everything is kind of intertwined. These are separate entities. So how do we get all these farms connected to each other and connected back to us here in Ohio? Good solution is a gateway network. The idea is kind of you replicate scope. So the idea is it's easier to deploy this, cost less. You're not having to reinvent. You have 5 different devices that you're programming different applications. Would be one. And then quick deployment. Ultimately, we'll take a device, copy it, and paste it. Ignition uses the term backup and restore, same premise. We do it once, we do it again, we keep adding sites to our farm. So eventually we come back to that hub and spoke model. So pretty simple. The first time we did this, it was a challenge. We made the main gateway. That in itself is its own application. And then you have all of the spokes, which are their own application. They are different sites, but they are basically ultimately running the same program. So this is kind of, it's not a live view, it's a video, but just to give you guys a sample, this is our sensor screen. So we kind of went over this, but these are all the sensors, the various vendors. What's really cool here, you can tell based off what connection we've got. So Gale has their system. So quickly you can come here and identify, what vendor it's talking to. And what's neat on this is these are settable. So the text and all that, we created a UET, which allows you to customize this. So the biggest thing with this application, we talk about scalability. So here's the trailer screen. So again, as we add farms, what's really cool is once an edge device gets connected, this will actually generate another row. So it's kind of, again, these are widgets on a dashboard, but it's set up in a way that I don't have to, add a new one.
Generally speaking, our relationship with the farmer is manure management for them is always the bane of their existence, but it's really important for operating successfully. So we lease land as a company. All the cost to build this is our capital, and then we kind of have a revenue share with the farmer. But to them, they want to out of sight, out of mind. We're getting in, helping them with the problem that they have, and being a solution provider, with the farmer, and then also an additional revenue stream for them. And we give them summary reports, and a lot of those summary reports really ultimately come from that EPA data tab that rolls up into a simple Excel sheet we send. Further, we actually intentionally, per our corporate IT, didn't type. Which is one of the kind of challenges and reasons that this works. So every single site has its own internet provider. I cannot VPN into a farm. So either we're opening ports and firewalls, or we have something like this that can actually call out and push data, and so right now that is actually where we landed because we didn't want to open ports and firewalls. It's not on the VPN, so I can't easily access it, but most of the data that we ever need is now here on this centralized server, and then the operator, if they're at home and they really need to go in to change a set point on a piece of equipment or restart something, they have to virtual machine into whoever's called into the desktop that's on site, and then they can control from there. What has been created here is pretty cool because I have not seen a solution quite like this. Most plants, either it's a $100 million biogas plant and they have the really well integrated solution, right? But I think those rollouts are very intense and they're highly customized to that facility. So we've actually thought about selling this service as a package and calling it like a back office management package, because we already know from a data point perspective now we do know what we didn't know before, and we know what the EPA is looking for, exactly what we need to collect, and given the flexibility of this solution, you could take this box and put it in any biogas site, interface with, I'm assuming, most or any vendor to collect the critical data that's needed for the EPA, which really was the driver for this solution. We knew that having the data, we could start to overlay some cool stuff, but like our number one goal, we call our cash register data. It was just like, I don't care about the screens, I don't care what it looks like, I don't care about fancy graphics, I just need that data.
I mean, you eventually did this.
But we're definitely in this. Every conference you go to, everywhere you look, we're talking about digital transformation, right? And what does that really mean? Where do we get started? There's a lot of noise out there that's been created over the years as to lots of different platforms. Of course, now AI is entering the scene. There's a lot going on. And what we really know is that from an OT perspective, that I come from the operations world. I was an integrator for a number of years myself. That we have to solve the challenges that are there, right? We have to have solutions that work for our operations. But ultimately, we're trying to reduce a lot of manual work, paper, clipboards, whiteboards. We want to be able to bring data in so that we can store that information and take advantage of that information. We do know those pieces are really important, but it's how can we really get started with this journey? What is it? But it's about process improvement through digital technology, right? So at the end of the day, we want to make operations better, and we can doing that, leveraging different technologies that are available to accomplish it. I would say in order to digitally transform, we have to have that right foundation, and I think that SCADA is in a unique position to really be the anchor point of our digital transformation journey. If we can get that layer done right, it allows us to go a lot further. And then we also know, of course, data is king these days, right? So this is, data is paramount. And the way that we've been doing it for so long in that realm is you build your SCADA system, you connect to the data that's required, and you fulfill that requirement. You go to your MES, you go to whatever systems there are, and you kind of build those more or less inside of arenas. Connected bridge, the OT-IT jack, and that is fundamental part. And that for so long, OTs don't come in IT. We want this to work. Don't mess with our systems. But IT wants to be able to come in and leverage some of the technologies that they're used to. We have been working in this paradigm for a very, very long time. You're probably very familiar with the automation pyramid and the layers that are there, from machinery to PLCs, of course, to SCADA, to the MES layer, of course, all the way up to ERP. And it's very common model. It's been around for a very long time, where layers provide their functionality. Layers, typically you kind of go down, but not necessarily up. Although those lines have really blurred quite a bit, because what we have tried to do is connect all these systems together. And as demand has happened, we need data from, obviously SCADA needs data from PLCs, but then we need to bring that to MES and ERP, and we're kind of sidetracking. And it's been an interesting kind of ride in terms of how we've been protecting the OT operations, especially with network segmentation and firewall rules and all these crazy things that are happening, just to be able, to allow people to do this. business. Right? But it will be to even do control and control in a secure, reliable way. And we have Edge of Network that's entering the scene. Edge of Network is adding a lot of benefits, from store and forward to local HMIs to even compute, where we can actually run various workloads at the Edge of Network. Especially, and so that's where there's some exciting things around. Definitely machine learning and artificial intelligence, where we can actually do inference at the edge, and where it makes sense. But scalability is probably the most important thing. In order to really achieve scalability, architectures have to be done in a correct way. We have to think about our data differently, and we'll get into more specifics around this. And we have to do all this around, of course, cybersecurity concerns, right? Making sure that that's the forefront in how we are approaching our systems, that we're thinking about cybersecurity from the ground up. And we also have to look at licensing models that are not restricted these days, where we have to be able to go to things that are unlimited or certainly more flexible and agile. Now, clearly, Ignition is unlimited, so it's got to be systems got to be based on open standards. We can't have closed proprietary systems anymore. We have to leverage standards out there so that we get interoperability, that we can choose best-in-class products that can work together, and that could be a layered approach in our networks. We have to work with multiple operating systems. We're in a world where deployment is changing. It's not just Windows. There's Linux. There's containers. There's Kubernetes. There's a lot of different ways. Edge devices, various things that we have to kind of work around. So are both on-premise and now it's kind of bringing into the cloud. You saw that previous example where there was the on-premise, the edge device that's out there collecting information, setting that up to the cloud.
And data collection for their powerhouse equipment, resulting in unreliable equipment performance. We developed ignition screens to monitor 4 Rockwell PLCs and displayed equipment status, utility consumption, and system performance. And we were able to transmit water, gas, and electrical data to multiple plants. This project, the customer lacked a centralized remote monitoring and alerting system for their environmental testing process. This increased the risk of undetected set point deviations, product quality, and compliance requirements. We developed custom ignition perspective dashboards that were created to display facility conditions, trends, and alarms. And the cool thing about this project was we were able to trigger video capture of the testing through Ignition. Okay, an existing Rockwell RSView32 application. We mimicked the application almost identically, and this helped the operators with their transition from one platform to another platform. The need for physical equipment and easy transport. We duplicated the system process in Ignition to help users with their product assembly, operation, and troubleshooting. All the equipment was replicated and all setup scenarios were developed for testing procedures.